Probably going to do this, you're going to square 64 and then you're going to factor it and you're going to look for a number times itself 3 times it equals 64 squared. And oh my gosh, that is so ugly. So we're going to talk about caveman math. Have you ever wondered what kind of math you'd have if you were never taught anything? I mean, are babies born with math? Is it something that we as humans develop as we mature? My name's Philip Brown. I'm the bearded math man, and I'm going to answer that question for you in a way that will help you learn how to handle rational exponents. Yep, believe it or not, primitive peoples, like in the Amazon, and there's been some research and studies that have shown this, they think about math, they think about numbers logarithmically. Relationships with exponents, not addition. Kind of strange. Surprises me, but let's take a look. If you asked a primitive person, what is 3/4 of 16? Well, to us, first of all, we would say 12, right? Because 4 goes into 16 4 times, and 4 times 3 is 12. But that's not what they would say. They would say it's 8. And here's why. They think about this as exponents. See, to them, 16, the way you get to 16 is by multiplying 2 together by itself over and over and over again, not by adding things together. 2 times 2 times 2 times 2 is 16. There's 4 2's being multiplied to make 16. See, 2 times itself 4 times would get you 16. The third of those is 8. 2 to the third power is 8. Now, this is what we asked them, but what they actually would interpret, the way we would write it, is like this: 16 to the 3/4 power. Man, now we could rewrite that with radical notation, but you kind of lose the meaning, but I'll show you what it looks like anyway. Those two things mean the same thing, and that's what primitive people without any sort of mathematical education, that's the way they think about math. Now that is really cool. Now I'm taking a couple of little liberties here to kind of strike a point and introduce this kind of math, but if that is an interesting topic to you, in the description below, I will put a link to a Radio Lab podcast that talked about just this thing. 27 to the 2/3 power. A lot of the time you might see it written a different way, like this. And that's kind of ugly. It's kind of confusing. I mean, it doesn't all make a whole lot of sense. This is really saying, hey, look, if you're going to multiply a number by itself 3 times to get to 27, well, what's the second one? What's the second step? The second step would be 9, you see? Let's try one more. Let's try 64 to the 5/6 power. Now that's saying, look, is there a number times itself 6 times that equals 64? And if it is, what's the 5th step? That's what that's asking, right? So 64 turns out to be 2 to the 6th. So 2 to the 5th would be the 5th step. You see, 2 to the 6th is 64. The 5th step, right here, the 5th step, right, 32. That's pretty cool. Now I'm going to show you some procedures in just a minute to help you handle that if it gets a little sticky, but that's where it comes from. That's where all the steps are going to come from. That's what this means. This is saying, hey, look, is there a number times itself 6 times that equals that? And if there is, what's the 5th one? What's the 5th progression? Now let's take a look at this one right here. This is 64 to the 2/3 power. That would be the same as this. Man, and that's kind of ugly. See, what you're probably going to do there is you're going to square 64 and then you're going to factor it and you're going to look for a number times itself 3 times it equals 64 squared. And oh my gosh, that is so ugly. Now, if you recognize that 64 is a perfect cube, 4 cubed, well, that's asking for what's the second step. So this would go 4, 16, and 64. There's the second step right there, 16. Now let me show you some math right here. Let me show you some procedure that we can do right here. Now, first thing is you have to notice that 64 is a perfect cube. Do you see? You see what I did right there? 64 is 4 cubed. 4 cubed is 64. All right. Now, a power raised to a power, you can multiply those. I think 2/3 times 3 is just 2, right? 2/3 times 3. So this whole thing right here, 4 squared, of course, 16. Dang! Now what if we had something like this? 81 to the 2/3 power. 81 is not a perfect cube, unfortunately. It's 3 to the 4th. It's also 9 squared. Huh. But check this out. 27 times 3, right, is 81. 27 is a perfect cube. You see what I did there? I just broke that 81 apart into 27 times 3. Now, do you see why I did that? The reason I did that is because of that 3 right there. You see, if this was rewritten with radical notation, you can see that's cube root. We're looking for a number times itself 3 times it equals 81 squared. 27 is 3 cubed, right? Okay, so I'm going to rewrite that as 3. Okay, you see what I did right there? Okay, now, everything inside this parentheses gets that exponent of 2/3. So I have to multiply this 3, the exponent of 3 by 2/3, and this 3 has an exponent of 1, but we don't usually write it, right? So 2/3 times 3, famously known as 2, and 1 times 2/3. Kind of ugly, right? So this is 9, and what's left over is 3 to the 2/3 power. So I would actually say that maybe the best way to do that would be let it like that. Sometimes this is a little neater, and sometimes this way is a little neater. You have to be proficient at switching between both. And it's just a different way of writing the same exact thing. So let's try one more example, shall we? Let's try 625 to the 3/4 power. Now keep in mind, math is set up to be easy. Problems in books, you're usually going to have an answer that's okay. Now, if you're doing some applied sort of math, you'd probably be using a computer or a calculator, and you just get a decimal approximation for that. But in math class, if you're given something like that, you're probably going to have a nice, pretty answer. So when I look at 625, I recognize that's 5 to the 4th power. 5 to the 4th power, and that's a 4 in the denominator. This is saying, hey, look, if you have a number multiplied by itself 4 times, what's the third one? I think the third one's 125, so I'm going to just write 125 as a guess. I didn't do any sort of calculation, or I didn't use any sort of trick. I just thought about, what is this asking? 3/4 power. The exponent 3/4 is saying, hey, look, what is 3 of the 4 steps on its way to 625? All right, now, let's see if we can do a little bit of math, like a procedure. If you can't figure that out in your head, like if it just doesn't come to you, what do? What if you're stuck? This is what you do. Ready? Now, you have to be familiar with, well, the powers of 2, the powers of 3, some powers of 4, and so on, right? So like all the powers of 2 probably up to, I don't know, 10 or 12, you probably should be able to recognize in order to be good at this kind of math. So 625 should be a number that you recognize as a power of 5. I mean, sorry, but there's no shortcut for that. You just have to recognize that. But once you do, you see what I did right here? 625 is 5 to the 4th. Now that's pretty cool, because you see that 4 right there? Power raised to a power, you multiply 3/4 times 4 is 3. Which is of course 125. So yeah, it doesn't matter which way you do it. You can do it either way. Now I'm going to show you one more way, the way I like the least, the ugly way with the radical notation. The math is not as fluid, it's not as powerful, it's kind of chunky and clumsy, but here, 625 cubed. We have to find the 4th root of that. Well, this means we're looking for a number times itself 4 times, and it needs to equal 625 cubed. Oh, that's ugly. Okay, so 625 is 5 to the 4th, and I have 3 of them. 1, 2, 3. Do you see? Now, I could rewrite like that. 5 to the 4th, 5 to the 4th, 5 to the 4th. The 4th power, each one of those is worth 5. This is 5, this is 5, and this is 5. And they're all multiplying. That gives you 125. This one's 5, that one's 5, that one's 5. 5 times 5 times 5, but that way is clunky. So, to review, if you had x to the power of a over b, that would be the bth root of of x to the a. Wow, that is so ugly. Ugh. Here's what it's saying. I'm going to try to make this generic, and then, oh man, we'll see how it goes. But this is saying x to the a over b power, right? That's saying if x is a perfect power of b, what's the 8? Sounds like a. What's the iteration a, right? That's what it would be. That's all it's asking. So let me put some numbers in there. Let's say that, we're going to talk about 32 to the 2/5. That would be this. Okay, you see how we have 1, 2, 3, 4, 5 2s, right? The 5th. So that's why I know I'm using 2s. And now this is asking for the second one. What's the second iteration? That would be 4. 2 times 2 is 4. That's all it is. So anyway, man, cave people probably a little more sophisticated than you think. Well, so I hope this video was helpful. Hopefully it was interesting. If it was, you could click like and maybe even subscribe and share it with other people. And visit my website, thebeardedmathman.com. There's all kinds of great stuff. Especially if you're a high school student, I'm going to walk you through your first day of high school as a freshman, all the way through the last day of your senior year with math. And for teachers, man, I got lessons, I got materials, I got not supplies. No, I'd love to give you guys supplies, but I got all kinds of materials for you that I think hopefully make teaching math easier for you so your students have better success. Anyway, I'm Philip Brown, the Bearded Math Man. Thank you for watching.